Good evening, dear students. Let us start our class on mathematical reasoning. This is the second session in continuation of our previous session. Here we will start with discussion on the negation of compound statements. Now, dear students, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly before I
Yes, sir.
further? Okay, thank you very much. Okay. So now, what is negation of compound statement? If you recall, dear students, the compound statement means what? If there are two statements, something like which we can represent by P and Q. Suppose one statement is P and another statement is Q. Then what is the compound? We understood the in a previous session. The compound means we can have that P and Q or P or Q. These are the two compound statements. Now, what we are going to discuss, we are going to discuss the negation of this compound statement. That means what will happen if we make the negation of P and Q, or what will happen if we make a negation of P or Q. That we are going to discuss now. And what will happen that negation of the statement P. Correct? So these are the three things we are going to discuss now, dear students. The first, what we are going to discuss about the negation of P and Q. Negation of P and Q, dear students, it is negation of P or negation of Q. Negation of P or negation of Q. And notice one thing very important. Here in the left hand side, there is and, that is the symbolic representation of and. But in the right hand side, what we get is that it actually becomes or. Okay. If you notice this thing, that in the left hand side it is and, right hand side it becomes or. Similarly, if we make the negation of P or Q, that means negation of P and negation of Q. And here also notice, dear students, that or is actually being replaced by and when we make in that negation of that one. And negation of a statement is obviously the original statement. So what you can write, that is equal to P. Correct? Obviously, if you make a negation of a statement, you will get this thing. Dear students, in the last session, I also told you that all these things are also important for physics chapter that is called logic gates. Not now, in the next year when you will be studying about that logic gates. Okay, there also you will find all these are coming back. Okay, dear students, so this is all about the negation of compound statement. Now, what we are going to discuss, about the the conditional statement. Now, before I proceed for discussing the conditional statement, I just want to write down exactly what I just did board work from the study material. Okay, just for your future reference. Okay, so whatever I wrote, this is the copy paste from our study material. Okay, so in view of negation of compound statements, please remember the following identities. Okay, and these are the identities has been mentioned. Okay, which I wrote earlier. Now, dear students, we are going to discuss about the conditional statement. Okay, and that we are going to discuss in details now. And that I'm going to discuss in the next page. That is the conditional statement. So, dear students, before I discuss further, let me explain you a few things. Let us consider P and Q be two statements. Then the compound statement forming by joining P and Q by connectives, something like that. If then is called a conditional statement. Correct or not? If you see that whenever we say that a conditional statement, it is something like that. If, for example, let me give you an example so that it will be very clear. That suppose I want to go out of my home. That is a statement which is true. Okay. Now, if it is raining, then I'll take umbrella with me. And if it is not raining, I will not take umbrella with me. So then here is a if and then is coming into the in context of our discussion. If it is raining, then I will take umbrella along with me. So that is a conditional statement. That means what? If it is not raining, then I'll just go, alone, means without taking anything with me, no umbrella. So this is what is called a conditional statement. So whenever the compound statement forming by joining the two statements by a connective called if then is called a conditional statement. Also, or an implication, and how it is written, that I'm going to show you. So, so let me first place the statement, dear students, and after that I will discuss in details. So here you see, dear students, so let P and Q be two statements. Then the compound statement formed by joining P and Q by a connective if then. So what is the connective here, dear students? Is the if then. Okay. Is called a conditional statement or an implication. And how it is written? It is written that P is implying Q, P then one arrow Q, or P then the double arrow Q. Double arrow Q means it is a implied operator, right? In several mathematical problem solving, you have used especially this one, P implying Q. P implying Q means what is that? If P happens, then obviously the Q happens. In a very light manner, you can think in this manner, without going to the details about the conditional statement. Whenever you see some statement like that, P then implying Q, that means what? If P has true, if P is having true, P is valid. Different way I'm saying, if P is valid, then it follows that Q is going to work. That means what? If P is not valid, then I'm not going to work on this, that Q. Correct. So that is what, in a very loosely manner, you can define about the what is called the conditional statement. Now, one thing is to be noted that the conditional statement, that is P implying Q or P arrow Q, is known as hypothesis or antecedent. Okay, that here P is known as the hypothesis or antecedent, and Q is known as the conclusion or consequent. So, so what I'm telling is that here that P is known as hypothesis. Okay, hypothesis, or it is known as antecedent. Okay, and Q is known as the conclusion or consequent. Conclusion, sure, let me write properly. Consequent, right? The conditional statement that P implying Q or P arrow Q, has several different way we can express, and that I'm going to let you know. So, so first let me inform that whatever I just said, let me copy paste from the study material, and here it is, that as I just wrote in the above about the hypothesis or antecedent and conclusion or consequent. Now I'm just going to tell you that what is the literal meaning of all this, P implying Q, or P is P arrow Q. So we know this is a conditional statement. So here the statement is, dear students, the conditional statement P implying Q or P arrow Q can be expressed in different ways. First, we can say is that if P then Q, which generally we used in solving mathematical problem. Or the other way we can say is that Q if P. Third one is that P is sufficient for Q. And the fourth one is that Q is necessary for P. Dear students, whenever you will be working with programming languages, okay, and then you will find this kind of constructs, this kind of statements, okay, are very meaningful. Okay, so if you note down all these four statements, that is if P then Q, or Q if P, or P is sufficient for Q, or Q is necessary for P, all are actually converging to the same statement and same conditional statement, that is P implying Q or P arrow Q. Now the point is that you may ask that, sir, then if this is the case, then why there are four such different ways? These are the four different ways that depends on the context. Whenever we say in context of just English statement, we say if P then Q. As I said, if it is raining, then I will carry umbrella with me. If it is a kind of programming language statement, then we can write Q if P. Or there are some necessary and sufficient conditional statement in mathematics. There we discuss about that P is sufficient for Q or Q is necessary for P. Okay, and not only in programming languages, there are some theoretical computer science. Okay, if you study theoretical computer science in future, if you research in that particular domain of computer science, that is called theoretical computer science. Okay, so these are the very foundation of the formal methods, formal statements. Okay, if you are very interested, dear students, and very interested to know more about it, then you can just give some Google search on formal methods, formal statements, formal languages. Then you will see there are lot of constructs, but the foundation of those constructs are from whatever we are discussing in this class and whatever we discussed in the previous session, and also what we will be discussing in the next few sessions as well. Okay, dear students, so this is all about what I wanted to discuss about that, the conditional statement. Now, as we understood about that conditional statement, the next statement, what we are going to discuss, is called the contrapositive of a conditional statement. The contrapositive of a conditional statement, and that is the topic that is the discussion what we are going to do now. So I will go to the next page and we will discuss about the contrapositive of a conditional statement. Okay, so let me first write down the statement, then I will explain it further. And I'm taking it from our study material and I'm just placing in front of you, dear students. The statement, if you see, let it first come, negation P implying Q, or P, is denoted by the P implying Q or P arrow Q. I hope you got it, dear students, what I wanted to mean. The statements, I repeat once more, the statement negation of Q implying negation of T, I cannot go to the office. Okay, so what I wanted to mean is that if my car is in the service center, then I cannot go to the office. And we need to find the equivalent contrapositive statement. So what will be the contrapositive statement of this statement, what you see in that in front of your screen, that if my car is in the service center, then I cannot go to the office. Okay. Now, to understand that, first okay, dear students, I got disconnected for a moment. I hope all of you are able to hear my voice, and you will be able to view the screen. Could you please confirm, someone please, that you are able to view the screen? And
Yes,
able
sir.
to, okay, great, thank you. So what I was talking about, that contrapositive of a conditional statement. So we just discussed that if we have a statement P implying Q, so suppose we have a statement P implying Q, or it is denoted by that P arrow Q, both are synonym in this context. Okay. So if you see, the P is the statement my car is in the service center, and Q is the statement I cannot go to office. That means if P is true, then Q is true, isn't it? That if my car is in the service center, then I cannot go to the office. Or Q if P, if you remember the previous session, that Q means I cannot go to office if my car is in a service center. And we also discussed in the previous session, if you look into it, that P is sufficient for Q. That means what? If my car is in the service center, that is sufficient for to conclude, this is sufficient to conclude that I am not going to office. I cannot go to office. Or Q is necessary for P. Q is necessary for P. That means what? I cannot go to office. And to have that statement true means I cannot go to office. What is necessary? That my car should be in the service center. So now look into this one. What are we going to discuss? We are going to discuss the contrapositive of this statement, of this conditional statement. Now, according to the definition, what is the contrapositive of this conditional statement, dear students? So this is our original statement. So just a minute. This is the original statement. Let me make it in the box. So what is the contrapositive then? Contrapositive will be something like this. Its contrapositive will be, I'm going to write it here, dear students. It's something like this, that not Q is implying not P. Or we can say that, not Q, just a minute, let me write not properly. Not Q is arrow, not P. So that is what is called the contrapositive. Okay. Now, in context to the discussion what we are having, that P is the statement my car is in the service center and Q is the statement I cannot go to the office. What will be the contrapositive statement? Now, to understand that contrapositive statement, what we need to do? We need to do that what is negation of P? The negation of P is that my car is not in the service center. If P is the statement that my car is in the service center, then what is negation of P? That my car is not in the service center. And what is negation of Q? That I can go to the office, because Q is the statement I cannot go to office. I cannot go to the office. Then negation of Q should be I can go to the office. Pretty simple. That I hope all of you understood that about that, negation of P and negation of Q. Correct. So if you look into this one, dear students, I use a different color. So this is the statement P. My car is in the service center. Then this is the statement of negation of P. My car is not in the service center, if you look into it. And the statement Q is that I cannot go to the office. And you see the negation of Q is that I can go to the office. So first we understood that what is meant by the negation. Now let us now concentrate on that what will be the contrapositive statement. Contrapositive statement we just understood, it is not Q is implying not P. That means in English statement what we can say is that I can go to the office, or if I can go to the office, then my car is not in the service center. Isn't it, dear students? That so the contrapositive statement of the given statement is that if I can go to the office, then my car is not in the service center. I hope you got a very clear idea about it. And dear students, as it is mathematical reasoning, it may take some time to have a very clear idea about it. So what was our original statement? Original conditional statement. Our original conditional statement was something like this, that if my car is in the service center, then I cannot go to the office. And what we get the contrapositive of this statement as if I can go to the office, then my car is not in the service center. I hope you got a very clear idea, dear students, about the contrapositive statement, contrapositive of a conditional statement. Now the next point what we are going to discuss, dear students, is called the converse of a conditional statement. Converse of a conditional statement is what? That we are going to discuss now. Okay. So think about a conditional statement something like that, Q implying P. Okay. And that will be the converse of the conditional statement P implying Q. Correct or not? So what I wanted to mean is that suppose you have a statement P is, just a minute. Suppose we have a statement something like this, that P is implying Q, or P arrow Q. Correct? Then what will be the converse of this conditional statement? This is a conditional statement we are aware of. This is a conditional statement. Okay. Now, what is the converse of this conditional statement? So its converse what we are going to discuss now. So what it will be its converse? So its converse will be, dear students, that Q implying P or Q arrow P. So if I use a different color, so it will be something like this, that Q is implying P or Q is arrow P. That is known as the converse of the statement what I marked in the red color. Clear, dear students? So let us take an example. The same example, my statement will be the remain same. If we consider a statement something like this, if my car is in the service center, then I cannot go to the office. And what will be its converse? If I cannot go to the office, then my car is in the service center. So let me write it down and then we will discuss once more. So if you look into the statement, what I was actually referring to is something like this. Okay. So what was the example, dear students, is that, for example, if the statement is something like this, if my car is in the service center, then I cannot go to the office. Okay. If my car is in the service center, then I cannot go to the office. That is my original statement. And what will be the converse of this statement? That converse of that statement will be, if I cannot go to the office, that means the last statement becomes the first one, last simple statement. That last simple statement of the previous conditional statement. I cannot go to the office. That actually starts with, if I cannot go to the office. Okay. Then what is the last statement of the, the first statement of the previous statement? My car is in the service center. That becomes the last statement of the converse of that statement. Note it down very clearly. If my car is in the service center, then I cannot go to the office. Converse of that statement is, if I cannot go to the office, then my car is in the service center. Dear students, I hope you understood what is meant by the converse of a conditional statement. Okay. Now, what we are going to discuss, that is called the biconditional statement. And that will be the last topic for today's session. And I'm going to discuss about this in the next page. That is the biconditional statement. Let us understand biconditional statement. And here also we will take that two statements P and Q. Okay. So let me first, write down the statement, dear students, and from the study material, and followed by I will explain exactly what is meant by that. Okay. Let P and Q be two statements. Let P and Q be two statements. Okay. Then the compound statement formed by joining P and Q by connective if and only if. The connective here is if and only if. That is also known as IFF. Is called a biconditional statement and is written in symbolic form like that: P implying Q or implied by Q. You see, there is a by die. That means what? P, it is implying Q, and Q is implying P. That means, in other way we can say is that, P is implying and implied by Q. Or we can write this thing as P, the arrow is in the both the direction, that is why it is called biconditional. Okay. Or by die, I said bidirectional, as long as the arrow is concerned. Then I said that by die, bidirectional. And in statement we can say biconditional. I repeat, dear students, let P and Q be any two statements. Then the compound statement formed by joining P and Q by a connective if and only if, or IFF, is called a biconditional statement and is written in symbolic form as P implying Q or implied by Q, or P arrow, both side arrow Q. Correct? Now, it will be very easy if we can, take an example and discuss further. For example, let us consider two statements, something like this, that the statement P is, ABC is an equilateral triangle, and the statement Q is that, ABC is an equiangular triangle. Correct, dear students? So what we are taking here? We are taking two statements. The first one is P. It represents that ABC is an equilateral triangle, and Q represents ABC is an equiangular triangle. Now the biconditional of that statement P and Q is represented as ABC is an equilateral triangle if and only if ABC is an equiangular triangle. Let me repeat once more in case I made any mistake, any slip of tongue. That the biconditional of the statement P and Q is represented as ABC is an equilateral triangle if and only if ABC is an equiangular triangle. Our statement P is that represented by ABC is an equilateral triangle, as you see here. ABC is an equilateral triangle. And what is the statement Q? Statement Q is that ABC is an equiangular triangle. Now, the biconditional of this statement P and Q represented as is something like, ABC is an equilateral triangle if and only if ABC is an equiangular triangle. Literally we can say that if ABC is an equilateral triangle, then ABC is an equiangular triangle. Or we can say, if ABC is an equiangular triangle, then ABC is an equilateral triangle. Both are true. That is why it is implied and implied by, bidirectional. P is implying Q. So other way we can write that P is implying Q Just a minute. Let me check whether I got disconnected again or not. No, I'm there. Okay, P is implying Q. And also we say that Q is implying P. If we join these together, then what we are going to get? P is implying Q and implied by Q. I hope you got a very clear idea about the biconditional statement. And with this, I would like to conclude the class for today. In the next class, we will discuss about quantifiers. Then we'll discuss about validity of statements. Then we'll discuss about some more discussion of validity of statements, and that will complete our entire discussion of mathematical reasoning. So with this note, dear students, let me conclude the class now, and we will have our class tomorrow at the same time. Thank you very much.